Hi, I'm developing a game. I've been doing it for a while and I wanted to document my progress. So here's a list of everything I've made so far, and a few times I'm going to walk you through my code logic because I think it might be interesting. I settled on the premise that the point of the game would be to encourage speedrunning. I've heard about a game called Neon White which also does this, but the levels in that game are only about 10 to 30 seconds, which encourages playing over and over again to try and get the perfect run. The thing is, that's not what I find personally interesting about speedrunning. What I find interesting is playing long sections over and over again, and slowly seeing yourself understand the map further, and get used to the controls and the level elements. So the goal for this game is to have the whole thing be a 5 to 10 minute mini speedrun, and the faster your time, the more lore you get to uncover. The first decision was what game engine to use. I've decided on using Game Maker Studio because Toby Fox used it for Undertale, and he says it was very good for someone who's bad at programming, so maybe it can help me out. Sorry Unity, I just can't get my head around you. One of the first things I made was this map. I built in a couple of places where you're supposed to be able to skip ahead, so the intended path looks like this, but if you experiment enough, you might be able to find this way instead. I have been inspired by Hollow Knight to include skips like this, although the map might look different in the final game, of course. One of my first tasks with creating this map was naming all the areas. One of the most important parts of any game. I've gone with the Hollow Knight approach: iridescent causeway, hollow depths, mirror point, etc. Although, if I redo the map at any point, I could see myself trying out the axiom verge approach and just making up some words. So, you may notice that the rooms are not all square. Now, having non-square rooms is actually quite a hard problem to solve. Axiom Verge 1 and 2 didn't even bother trying. Super Metroid and Cyber Shadow both seemed to manage it somehow, using witchcraft or something. And I found a game called Infernax where the map says that it solved this problem, but that's just a lie. It didn't solve the problem anyway, you can just see. To show you why this is such a hard problem to solve, allow me to show you this diagram. Now, if the camera comes to an outside corner, it's very simple to just move the camera to the closest point in bounds. But with an inside corner, the camera has to move dynamically when it should be caught on the edge, so it can move around the corner to catch up with the player. My system for this looks smooth, although a bit ugly during gameplay, but I think I'm happy with it for now. So here's what I came up with. In Game Maker, by the way, every object has a step function, which is called every physics frame. So this is the camera's step function, which decides where the camera is going to be every frame. So first, the camera checks to see if the player's X and Y are outside a bounding box within the camera. So this means that there's a dead zone in the middle of the camera, but if you move too far away from the middle of the screen, it will rush to catch up with you. If you're outside the bounding box, the camera will move relatively faster depending on how far away you are, but is capped at 7 pixels per frame. Next, it works out if it's colliding with any inside corners. Inside corners are these little objects that I can place in rooms, and they never move, so the camera will always move to the outside of them. For each corner piece in the current room, the code will loop through each one and mark which one, if any, the camera has gone past this frame. Intuitively, the camera can only collide with one at a time, although writing this, I have thought of this edge case where it could collide with 2 at once, so I might have to revisit this sometime in the future. So, current X and current Y are just the current edges of the screen that we're working with. And so if they're both on the other side of the edge, then that means we've had a collision. So if we're along this edge, the X position should be snapped up, and if we're along here, then the Y position should be snapped up. Next, and here's the bit that took me ages to work out. If the camera is here, but the player is here, then the camera needs to know whether it should try and move around the corner. Otherwise the player could continue going down infinitely and the camera would just be stuck on the corner. So, and in hindsight this is very simple, but this took me ages to get right. If the player is behind this line and they are within 7 tiles of this edge, move over. Also, if they are within 2 tiles, move again. The reason this was so hard is because this movement would interfere with the player trying to move the camera the other way, so the camera would just jitter uncontrollably. It also turned out that at one point the camera was moving the wrong way depending on which edge of the screen you were on. Finally, the camera does the simplest thing that it has to do, which is just check to make sure if it was outside the bounds of the room and go inside if it is. Then it just rounds its position to the nearest integer pixel. I'm amazed that this works as well as it does, and I still might have to revisit it at some point. The next thing I worked on was the player's moveset. This includes collision, which works by checking this homemade function, which lets you feed in the corners of a square and gives you back what it's colliding with in the background tile set. And if the function finds something, the player just moves back the way they came until it's not colliding with anything anymore. This function has a real habit of getting very flustered if you do something unexpected. But since I have no way of knowing how to fix this, let's just say it's a feature, since the game is about trying to understand your moveset. That's going to be my attitude a lot today. Then there's jumping. Now, jumping isn't as simple as you'd think. You can't just send the player up when you push the button and then let gravity pull you down again, because then it won't make you go higher if you hold the jump button down for longer. You have to increase the gravity somehow when you release jump. Other games do this in various interesting ways. Super Meat Boy stops all your momentum immediately when you release jump. The Messenger and Cave Story both only engage gravity once you release jump, or after a set period of time, and Outer Wilds, being a planetary simulation, doesn't change your gravity in the air at all. Instead, it makes you hold down the button before you jump, which lets you jump with a different amount of power, so the simulation isn't broken. I decided that the player would have normal gravity, but that when you release jump, you get a very high gravity until you're travelling back down, and then it goes back to normal, which it looks like is what Hollow Knight does. Next, objects that aren't the player. Now, good practice for programming is to find code that you'll have to write over and over again, and just put it in a function. So, what will all the enemies have to be able to do? Well, there's this enemy parent object that stores some code that every enemy will run on every frame. So let's look inside. First, if the player starts attacking on this frame, the enemy will set this variable connected to false. Then, if the enemy is colliding with the player, it will give the player this alarm, which triggers its hit stun and also knocks it back a short distance. Next, if the camera is too far away, move this frame is set to false. This will stop the enemy from moving and also stop it from using RNG and lagging the game. And finally, if this enemy is being hit with the player's weapon, it will decrease its health and set the enemy's state to hit or die, which will do different things depending on which enemy is using this code. It will also set connected back to true, so that the player doesn't hit the enemy on every single frame. So, now the exciting part, the player's abilities. In case you're interested, here's the player's create function, which initializes all of the variables that the player will need in its movement. If there's a yellow triangle, I haven't used that variable yet, but I'm quietly confident that I'll need it in the future. This struct upgrades stores the status of every upgrade in the game, i.e. whether the player has it or not. If there's dotted lines, I haven't made this upgrade yet. You can see some of the usual upgrades here, double jump, wall jump, Mega Man slide, but I'm worried that this moveset doesn't have its own character yet, in the future I want to buff some of these, like turning the double jump into a jetpack and making you invulnerable while sliding. I also want to make more of them into weapons. I'll get back to you about this in the future. So, there is one of these upgrades that I'd like to explain how it works, and that's the grappling hook. I want to make it like the grappling hook in Environmental Station Alpha, because I feel like that version has a lot of use for skips. I want to explain how it works because it's trigonometry, and I think trigonometry is very interesting. Or at least I wanted to flex my trigonometry understanding skills before I looked at this for about 5 minutes and realized I'd forgotten most of it. So if anyone in the comments has a bigger brain than I do, please tell me what all this code's doing, because I've no idea. Okay, finally, a few miscellaneous points. Often in speedruns, you ignore extra side pickups because they're just not worth it, like the size nodes and range nodes in Axiom Verge. So, I decided instead to make the ones in this game be more useful things, like speed upgrades, or jump upgrades, or health upgrades, things you might actually want to use. And crucially, they're things you can pick up for safety, but then as you get more confident, start to ignore. Like, I still remember the first time that I trusted myself enough not to take this safety save at Axiom Verge, so I could then save warp all the way back here. It felt so good to feel like I was finally good enough to get through this gauntlet in Iker, and then I actually managed it. This run is still my personal best to this day, so if I can manage to engineer any moments like that in my game, then that's a success. GameMaker includes its own random number generator functions, but I decided that all the randomness in this game would be from this table that I generated using random.org one time. The numbers are, and probably always will be, 21, 4, 2, 7, 13, 0, 9, 19, 18, 1, 23, 5, 11, 6, 20, 16, 10, 2, 17, 8, 14, 12, 15, 3. And then it repeats. Every time that a random number is called, it will take the next number in this table. So the game is technically 100% deterministic. Hopefully, that means that players will be able to learn patterns and plan what they'll do. However, RNG will definitely be called a lot, so it might be too difficult to track in your head. But you never know. I actually added a little feature where the player's idle animation goes faster if the next RNG value is small, and slower if it will be large. So that might be useful. The movement is currently very weird. The knockback appears to send you back a different amount depending on whether you were already moving in that direction. The attacks are very slow, and wall jumps are they're very strange. This is partly due to me being bad at programming, but partly because I'm currently watching a lot of the Super Metroid speedrunner Oats and Goats. It's given me a new appreciation for something that I think has actually been lost in newer games. For example, in Ori, you can play it and you've got controller shake and the backgrounds look like this and stuff. But watching a lot of Super Metroid, the just simple things are really hard. Like, with wall jumps, you have to angle away from the wall and back again. Or how to go in a ball at full speed, you have to already be running and then jump slightly. If the movement in this game was perfect, this kind of thing would never have had any way of existing. Because the movement in Super Metroid is so unrefined, that's what makes it fun to play over and over again. And yeah, so that's kind of what I want to have here. So even though the movement is really weird now, that's sort of a good thing. So I'm trying not to fix any of it. Oh, that's also why I'm thinking of including missiles and power bombs in this game, because resource management is quite a fun element in Super Metroid speedruns as well. So, when it comes to the game art, I'm no artist, but I've already made some water and some ground tiles, and I think I can do an adequate job. I'm hopeful that the goofy aesthetic will work to the game's charm. There's no sound effects or music, but I bet you're going to hear about it if I make any tracks for this game at some point. And that's all I have so far. My immediate to-do list now includes a bunch of things like fixing animations, creating new abilities, even doing some level design. I'm partially doing this because I'm currently in university doing a game design course, so I might be able to show this video to a future employer, which is why I want to clarify what I said earlier about not being able to understand Unity was in fact only true in the year before I started learning about Unity, and it was therefore a joke. I definitely understand it now, I promise, don't worry. Don't worry, I understand it. I understand Unity, don't worry, it's fine.